Okay, this is 10.4 and we're going to be talking about a transformation known as a dilation. Now, when you think about the word dilation, you could think about your pupils of your eye. When bright light shines in them, your pupils dilate, they go from big to small. Okay, or when you're in the dark, they might go from small to big, so they can get bigger and smaller. The only thing is we're going to be talking about a scale factor. When we talk about dilation, we want to know how much bigger or how much smaller an object is getting from its original. So let's try these. The shapes of each pair are similar. So this is similar to this, and this is similar to this. Fill in the missing side lengths. So if they're similar, and this side is 6, and this side is 12, what has happened to the length of, or happened to this object compared to this object? Well, it looks like from 6 to 12, it's doubled. So if this is 3, it has to double as well to be the same object, to be similar. So it goes from 3 to, this has to be 6 meters here. So this went from smaller to bigger, got bigger by a scale factor of 2. This triangle here, we've got this side length of 12, this side length of 12, and this bottom side length of 6. So if we make it smaller, we go from 12 down to 3. That means that we made it 1/4 the size, because 12 divided by 3 is 4. So that means we have to take this dimension right here of 6, and we have to make it 4 times smaller. So we take 6 and we divide that by 4, and that's just equal to the number 3 over 2, 3/2, which is 1.5. So to be the same scale, or the same object, we had to decrease this by a scale factor of 4. This one here, to be the same object, had to be increased by a scale factor of 2. Okay, so that's what happens when we dilate. We make an object bigger or smaller by a scale factor. So what is a dilation? The result of multiplying or dividing each length of the original figure by the same number to create a similar shape. Okay? A company makes small chocolate letters. Their customers want them to make larger size letters too. How can the company use a dilation to double, here's the clue, double the size of their chocolate letter molds? Okay, so they want to use dilation. Well, how do we do that? Well, it says join the dilation center C to vertex L. I'm going to have to give myself a little bit of room here. Okay, so what you're going to do is you're going to take your ruler and you're going to connect that point to that point, because we're going to make the dilation around point C. Then we're going to measure this. Okay, and you measure, what is the length of the line in millimeters? Okay, well, the length of the line is 15 millimeters from here to here. Okay, so what we're going to do is we're going to double everything. So double the length of line CL and mark point L prime at the opposite end. So we're going to double it. So that means we're going to go 30 millimeters away from C, and we're going to make it right about here. That becomes L prime. Okay, that point right there, that's L prime. All right. Draw lines from C to each vertex. Double each length to draw each vertex. Okay. So we can draw lines from here to here. And then what we do is we just double that line. Okay, and we go up. So whatever this measures from here to here, we double it, and we're going to go up to about here. And we're going to call that M prime. Okay, and then we can connect this one to right here, and then we can just double it. We can go all the way up to here. We double the line. Use your ruler. I'm not using a ruler, and it looks pretty crappy. But if you use a ruler, you'll get a nice drawing. That becomes N prime. Okay. Do the same thing here with O. Connect that to O, and then we can double it. Okay. Double the line. It comes to about here. So that's O prime. So you can see what we can do is we can start to connect these points that we drew right here. Okay, and we can do the same thing to P, and just double that length of line, and then that becomes P prime. and do the same thing to Q. Okay, we can connect that point C. This is similar to what we did when we did the rotation. Now we can double that, and we can get point Q prime. And we just connect them all. So you can see we've dilated this along this axis C, from this point C, and we've dilated it to be twice as big. Okay? M prime, N prime, O prime, P, Q, and L prime. Okay? So that's how you do a dilation from a fixed point. Okay? So let's complete the chart. What scale factor were the side lengths of the original letter multiplied by to get the enlargement? Well, the scale factor was 2. So what was the length? Well, the length of LM was 30 millimeters. The length of MN was 10 millimeters. The length of NO was 20 millimeters. The length of OP was also 20 millimeters. The length of PQ was 10 millimeters, and the length of OL was 30. So we increased everything by a scale factor of 2. We doubled it, so that means that this went up to 60. This increased to 20. This increased to 20. This increased to 40. Or sorry, this one increased to 40. Sorry. This one increased to 20, and this one increased to 60. Okay? What happens if you move the dilation center or double the connecting lines in the opposite direction? Trace the L on the paper and try it, keep the same scale factor. Well, I'll let you guys go ahead and do that. You can do the next example on here. Okay, just kind of understand that we're just talking about a scale factor. Okay, and you should have no problem doing it. All right, good luck.